Last but certainly not least, this time we're going to be discussing metamorphic rocks. All right, we have been everywhere on this diagram except for right here, a very tiny section. So you can see the way to get metamorphic rocks is burial, high temperatures, and pressure. So heat and pressure form metamorphic rocks. And you should see a familiar word here, metamorph, like metamorphosis. So the rock is changing to another form. All right, so again, how they form. Heat and pressure. So this is heat and pressure from the land above, and also magma and things below. So all of these in here could be metamorphic rocks, and even right here could be metamorphic rocks. Okay, so this could be either in contact or just not in contact, but heat and pressure from the earth cause other different types of rocks to turn into a metamorphic rock. All right, so like I was just talking about, you can have regional or contact metamorphism. So are the metamorphic rocks changing regionally or because they were in direct contact with some magma? So you can see here number 1 is going to be your contact metamorphism. So these are all going to be metamorphic rocks that formed from contact with the magma. Whereas number 2, oh, that's hard to see. So I'll write it right here. Regional. So that's like all of these areas here. Heat and pressure just from the inside of the earth is going to change those rocks into metamorphic rocks. And that's going to be how most metamorphic rocks form, is through regional metamorphism. All right, metamorphic rocks are classified. You can kind of look over here and see for yourself. They're either classified as what we call foliated or non-foliated. So foliated means that they are layered in some way, and then non-foliated, they are not layered in some way. So this is a very layered rock right here. This is gneiss, G-N-E-I-S-S, silent G. So this has very obvious layers of minerals. Some of them are subtle layers of just layers in the rock. It looks like sheets in the rock. And then down here, you can see here, we have a non-layered rock because there are no layers. There's no, it just all is one color. Okay, so a little bit more about metamorphic rocks. Foliated metamorphic rocks. We're looking at layered metamorphic rocks. So from shale, which is the sedimentary rock, it was that gray, smooth one made from clay particles. When shale undergoes heat and pressure, it will turn into slate, which looks a whole lot like shale. It's got that gray color, but the rock itself is just kind of like, if you look to the side, there's some layers on it. Okay, more heat and pressure will give you schist. Okay, and then even more heat and pressure will give you gneiss. So that was that really pretty banded one. So that's lots and lots of heat and pressure have caused those minerals to arrange themselves in those bands. So again, as you go down this list, it's increasing metamorphism. So it's an increasing change due to an increasing heat and pressure. All right, non-foliated metamorphic rocks. So again, existing rock. Limestone, you may remember, is also a sedimentary rock made of shell fragments. Once it undergoes heat and pressure, it metamorphosizes into marble, which is what we have down here. And then sandstone, also a sedimentary rock. When it undergoes metamorphosis, it turns into quartzite. Oh, that looks like that arrow is pointing at quartzite. Okay. And last but certainly not least, we have a metamorphic rock scheme. So again, we look at what's on our axes. So we have non-foliated and foliated. Those are our types of textures. So when you're looking to identify a rock, that's the first thing you're going to look at. Is it layered or is it not layered? that will immediately eliminate half of the rocks that it could be. Okay, these map symbols can also be some help because that actually looks a lot like gneiss. And then this actually looks a lot like marble. Marble kind of looks crystally, sort of like that. Okay, coal is black. That's why it's like that. All right, you have your grain size and increasing metamorphism. Okay, so that's why gneiss is at the bottom. It's the most banded. This is going to be the least layered up here at the top, or the least obviously layered. Okay, it tells you in here type of metamorphism. You see all of these are regional. We have a regional for coal, contact, and it could be regional or contact for some of those other ones. Okay, and then it tells you some comments about each of the rocks, and then you have the rock name. So when you're going to identify it, you would look at texture, okay, foliated or non-foliated. If you're non-foliated, you're going to want to do an acid test here because we have one that's made of calcite. So if it reacts with acid, it is for sure marble. Okay, if you're looking at the foliated ones, you're going to be looking to see which one is more layered or less layered. All right, so you'll be using this and another table in order to identify some rocks, metamorphic rocks, in a virtual lab.